Welcome to Future Forward, where we explore innovations shaping our world. Today, we're diving into the dynamic field of chemical engineering, which is undergoing a massive transformation. The driving force? An urgent need for sustainable solutions to global challenges like climate change and resource depletion. This means a strong focus on green processes and the exciting development of carbon-negative technologies. At its core, sustainable chemical engineering is about designing chemical processes and products that minimize or eliminate hazardous substances. Think about it: reducing pollution, waste, and energy use. It's about moving from a take, make, dispose world to a circular economy, recycling, reusing, and recovering valuable chemicals, all while ensuring safety for workers and communities. So, what are the key trends making chemical processes greener? First, there's a big shift from fossil fuels to renewable feedstocks like biomass, plants, algae, and agricultural waste for making fuels and chemicals. Then there's green chemistry, which focuses on finding safer, less toxic alternatives, especially for solvents. Water, ionic liquids, and supercritical CO2 are replacing harsh chemicals. Catalysis is another game changer. Developing highly efficient catalysts can speed up reactions, allow them to run at lower temperatures, thereby saving energy, and increase product yield while minimizing waste. We're even seeing advances in enzyme engineering. Process intensification means designing more compact, efficient processes that cut down on equipment size, energy, and waste. Bioprocessing uses living organisms to produce chemicals, leading to biofuels and bio-based plastics. And let's not forget digitalization. AI and machine learning are optimizing efficiency and reducing waste in real time. Even eco-friendly packaging is part of this green wave. But the ambition doesn't stop at just reducing emissions. The focus is now shifting towards technologies that actively remove more carbon dioxide from the atmosphere than they emit. These are carbon-negative technologies. A key area is carbon capture, utilization, and storage, or CCUS. This includes direct air capture, literally pulling CO2 from the air, and BECCS, which combines biomass energy with CO2 capture. Once captured, CO2 isn't just stored, it's being transformed. Scientists are engineering microbes to convert waste CO2 into useful chemicals like acetone and isopropanol. Imagine recycling waste carbon into new products. Captured CO2 is also being incorporated into building materials like concrete, creating structures that act as carbon sinks. Advanced materials like metal organic frameworks are being developed for more efficient CO2 capture. And emerging technologies like alkaline thermal treatment use biomass to produce hydrogen, potentially with negative carbon emissions. Of course, this green revolution faces challenges. Scaling up these new technologies from the lab to industrial levels cost-effectively is a big hurdle. They also need to be economically competitive. Significant investment in infrastructure and workforce training is required, alongside supportive government policies. Despite these challenges, the future of chemical engineering is undeniably linked to sustainability. By embracing green principles, improving process efficiency, and pioneering carbon-negative solutions, chemical engineers are crucial in building a more environmentally sound and economically resilient future. Innovation, collaboration, and a commitment to a circular economy will unlock the full potential of sustainable chemical engineering. That's all for this episode of Future Forward. Join us next time as we continue to explore the cutting edge.